Before you get scared, let me tell you, today's video is brought to you by turtles, an inspiration from one of my students. Our notes today are 5-3, crazy parallel lines. And look for turtles as we go through in our notes. We're going to be writing a little information, definitions about parallel lines at the top. Then we'll be going through 2 different scenarios, and then we'll be going over some questions as well. We're going to start off with the basics of parallel lines. Now, what you know is that these are 2 lines that never touch and that are the same distance apart, always. What I'd like you to do is pause the video and come up with 4 different things that you can think of that have to do with parallel lines. Anything can be about angles, can be about their distance, their definition, and unpause when you're ready to go. Okay, let's see how you did. If I move my little turtle out of the way, here are some things that I came up with. Number 1, maybe corresponding angles are congruent. Maybe that's something you put in there. Or that alternate interior angles are congruent. Maybe that same side interior angles are supplementary. Maybe that the symbol for parallel lines is 2 lines like this. Or if you want to prove that parallel lines are parallel, then you'll need to show that those angles are either congruent or supplementary. Make sure you have 4 things there. Now let's go into our scenarios. Now this is the first scenario, so make sure you save some space. We're not in the dissecting a problem portion yet. Now the first thing I'd like you to do is to grab a marker. Your pen or pencil is going to be the given information, and the yellow or orange in my case marker is going to be the conclusion. Here's the picture. This is what's given. Well, first of all, instead of having 1 set of parallel lines, we have 3 parallel lines. That's crazy. All right, if these 3 lines are parallel to each other, and let me highlight this here, and AB is congruent to CB, so these 2 sections right here, then what can we say? Well, I'm going to grab my orange marker. If this is true, then I can say that these segments are congruent. Or to complete the theorem, then DE is congruent to EF. All right, so that's your theorem. If you're given parallel lines and that they're an equal amount away from each other, then that means that the other transversal is also congruent on either sections. So I hope you know that. Here's your second scenario. Again, this is our given information is our pen, and orange is our then. Here's what's given. In this case, I have a triangle, and I have this middle line that happens to connect one midpoint to another. And I know that because this section is given as congruent to this one, and this section is given as congruent to this one. If those are congruent, then I can say that these 2 lines are parallel. Then DE is parallel to BC. Now hold on to your horses here. There's actually one more thing you could say. You could also say that DE is half of BC. So let's recap here. There are 2 conclusions if you're given a triangle like this. You can say that these 2 lines are parallel, and you could also say that this section right here is half of this bottom section. 2 conclusions. Now let's put this into practice. In the bottom of your notes, I'd like you to write the title, Dissecting a Problem. This should be about 1 inch wide right here, this distance, and we're going to be doing 2 main problems here. And this is how we're going to dissect it. You're going to be looking for given information in the picture. Were you given parallel lines with congruent spacing in between them? Well, then the question is, well, then what else is congruent? That's from our first scenario. Or were you given a triangle with a line that connects the midpoints? Well, then in that case, you're asking yourself which lines are parallel or which section is half of the base. So it depends on what you're given to decide what you can conclude. Now I'm going to be switching slides here. We're going to do question 1 in this space and question 2 here. Make sure you reserve some space here. So here's our first scenario. And again, make sure this is only half of your section here. Question 1, this is what I'm given. Looks like I have some lines here cut by 2 different transversals. Here's what my first question says. If AB equals 5, then AD equals what? Okay, so I have to ask myself, what was I given? Was I given parallel lines with congruent spacing, or was I given a triangle? Well, for sure I have parallel lines here, 4 sets of them, and they are congruent by the way they're spaced. So what can I say? Well, by that theorem, if those are congruent, then these are congruent. Now right here, it says that AB is 5, so let's label it. I'm going to use my blue marker here. AB is 5. So if that distance is 5, then what is AD? They're talking about this whole section from here all the way down to here. What's that distance? Well, I know if this is 5, so is this, and so is this. So all 3 would equal 15. Now, if I take these guys out of here, I have one more question for you. So I'm going to move my little guy away from here. This question I'd like you to try on your own. So here's your second question for the same diagram. If AC equals 12, then what is CD? If AC is 12, then what is CD? I'd like you to pause the video and unpause when you're ready, and we'll go over it. Okay, with this given information, if AC is 12, they're talking about this distance right here. If that whole distance is 12, then that means one smaller section is just 6, meaning this section is 6 also. So from C to D, that's 2 segments together. That would also be 12. Okay, let's move on to our second scenario. Oh, I forgot to write down. This was AD 510. Oh, 15 is what we wrote here, right? Okay, next section. Okay, for our last dissecting a problem question, here's what we have. Here's our given information. Again, we're dissecting it by asking ourselves, what were we given? And in this case, we were definitely given a triangle, and there's a line here that connects from one midpoint to another. What can I say then? Then I could say that this line is parallel to this line. And what's the second thing I could say? I could say, let me change colors here. I could say that this line is half of this line. Now, how's that going to translate to my math here? So here's what I know. 3x plus 5 does not equal 12x minus 8. It's not equal to it. It's half of it. So 3x plus 5s, 2 of these would be equal to the bottom. Now to do this math, I would get 6x plus 10 equals 12x minus 8. Now to solve this, I would subtract 12x from both sides to get negative 6x plus 10 equals negative 8. I would subtract 10 from both sides to get negative 6x equals negative 18. And then I would divide by negative 6 on both sides to get x equals positive 3. And that's how I would solve for x. So I just want to recap one more time in case you missed it. This purple line in the middle is half of this line. That means 2 of these would equal this one. That's why there's a 2 here. All right, you may want to write a hint to yourself right here to explain why there is a 2 there. So that's what I would do. Okay, go ahead and move on to your next tier. Great job.